Here's a quick tutorial on how to use Vesta to simulate a powder X-ray diffraction pattern. So open up your CIF file. I have silicon as a reference. Go to Utilities, scroll down to Powder Diffraction Pattern. This will open up this new window with 3 tabs: Conditions, Reflections, and Plot. And everything will be blank here until we click the Calculate button. Before we do that, we want to set up our conditions right. Right now, the default is to give us 2 different X-ray lines as our source. There's reasons why that might be useful beyond the scope of what we're trying to do here. So we're going to drop this down to 1 to simplify things. So that's 1.54. This is where you would change the wavelength of your X-ray source if it were something different than copper K alpha. For all patterns that will collect on CC's campus, we'll be using a copper K alpha source. So you can use this as default. Then you just click Calculate, and it's going to run. So then I can click over to Reflections. Here's a list of all my reflections. So this is just the tabulated number in the sequence of rows. So there's 13 independent reflections. Here's the H, K, and L for each of those reflections. Here's the D spacing that it computes. These are called structure factors, which is not something we need to fully understand here. Here's the 2 theta position in degrees, and then this is the relative intensity. So starting with 100% of that intensity and giving proportionalities thereof. So if I go to the plot, it's going to take these data and just plot it in the software for me. So each one of these red lines shows one of those peaks. Note that if you have more complicated structure, silicon is a really, really simple cubic structure with only one element. Very simple X-ray pattern. If we have a more complicated structure, then what we may get in our reflections are several versions of some permutation of HKL that all manifest with non-zero intensity at the same 2 theta. So that might mean that you have several hundred possible reflections, and in the plot, what you'll see is this green sort of hyphen that there may be many of those sort of stacked together. And all that's saying is that whatever peak that you have here is actually a composite of a variety of possible reflections all sort of lumped into that one peak. So if you use this tool to simulate, just know that it may be more complex and you may have more spectra lumped into each of these reflections. One last note of troubleshooting is that it is important that you have a good representative unit cell. If you have a reduced unit cell, which doesn't fully reveal the entire symmetry of the cell, meaning you only have a couple elements within the full cube, then that's going to give rise to not a great pattern. And so it may take a few attempts at finding a good CIF file before you find one that looks like this, where I have the full symmetry of the unit cell represented in the unit that I'm working with here. So that's just a cautionary bit of wisdom that if you're getting patterns that look strange, make sure you're not working with a reduced form or primitive unit cell, as they're called. Work from the full unit cell.